Alright, so today we are talking about geometric mean. So the geometric mean is a quantity between two numbers that is similar to an average, right? So normally when we talk about the word mean, we think average. And when you want to find an average, right, normally you would just add the numbers up and divide by 2. Well, a geometric mean comes about whenever we have a proportion where one of the numbers repeats in a diagonal fashion, right? So normally when we solve proportions, we do so by cross multiplying, right? So if we had a over x equals x over b, we would solve that by taking x times x, which is x squared, and a times b, which is ab. To solve for x, we would then take the square root. So to find a geometric mean, what you're going to do is multiply the two numbers and then take the square root. So the geometric mean of 9 and 4 is 6 because 9 times 4 is 36, and the square root of 36 is 6. So if we're looking at an example, say find the geometric mean of 8 and 10. So if you can't remember how to do it, right, always start with your proportion. The mean is the number we don't know, so what we're going to do is make sure that x is on there twice, and we're going to make sure that the x multiplies to itself so that we get x squared is equal to 80. So that tells me that x has to equal the root of 80. And so we know from our previous video that we need to break this down. So if I'm thinking of numbers that have square roots that multiply to 80, I know that 16 times 5 would give me 80. Square root both values. We know 16 would square root to 4. So our geometric mean is 4 square root of 5. So the next thing we want to look at, which is going to tie back into geometric mean in a moment, is the fact that when you have when you have a right triangle and you cut that right triangle with an altitude, meaning you take a point from one corner of the right triangle and make it perpendicular to the opposite side, what we're going to end up with is a pair of smaller similar triangles, right? And so when you look at the similarity statement and the way everything shapes up, the big triangle was ABC. That's going to be similar to ACD. Right? So notice A was in the large triangle. A is also in ACD, so they made sure to put that first in both. Notice they put the right angle as the last letter in the big triangle, so they're going to need to put the right angle of the smaller triangle last, and then of course the third angle is going to be whatever point was left over. They did the same thing for the smallest triangle, right? They made sure that B from the big triangle was in the middle, which means B is going to have to be in the middle again on the smallest triangle. They put the right angle as the last letter, which means the right angle again is going to be the last letter. And then the third letter of the triangle is whatever happens to be left over. So if I'm looking at an example and I need to write my similarity statement, I'm just going to take the big triangle and write it out in whatever order I feel like. So let's say we go FGH. So if I trace the big triangle, there's my FGH. Then what I want to do, if I can't really see how the other triangles shake up, or how everything lines up, what I'm going to do is draw the other two triangles separately so it's a little bit easier to see. And so remember we said that any angle that matches from the large triangle needs to be in the same spot. So let's say that I want to do the smallest triangle here. Well, I look at it, angle F is also in the big triangle. So if F was on top there, F needs to be on top here. The right angle was G in the largest triangle, and I put that second. So the right angle here is J, and then notice G was the other point on the smallest triangle. So when I do my similarity statement, I'm going to follow the same order. So F needs to come first. I did the right angle next, so that's got to be J. And then finally, the only letter I haven't written yet is G. So for the third triangle, the one I haven't drawn yet, I notice that H, let's go ahead and trace that out so it's a little easier to see. We're doing this guy. So H was the angle that was in both. The right angle is still J, and the other point is G. So when I write my similarity statement, G, J, H. So these are important to be able to set up because we're going to use them to solve our geometric means in the next example. So here we are, a picture that looks just like the one we had, only now we have some missing side lengths that we need to solve for. So if I want to sit and draw out my triangles again, I can do that in a way that will help me set up my proportions because we said in similar triangles, everything's proportional. So again, let's take the big triangle, let's draw it without the line in the middle. So J is here, L is here, K is here. So then, do that a little better. We need a second triangle. It doesn't matter whether I do the smallest one next or the slightly bigger one next. We just need to trace one out and make sure we've labeled it properly. So, again, the angle that's in both the largest triangle and the one I'm drawing needs to be in the same spot. So J needs to go there. Let's see, it looks like my right angle is at point M this time, and it looks like I have not written down the L, so there we go. We've taken the little green triangle, rotated it around so everything's lined up properly. And we need to do the same thing for this guy over here. So let's make a red triangle. See, our right angle this time is M. It looks like point K is the one that this one shares with the largest triangle, and then L is the one we haven't used. See, and notice how everything kind of rotates around. The last piece of this puzzle is to fill in the values for each side length. So if I look at it, from J to L, you should have a Y. It looks like from J to K, I've got 2 points, right? A 20 and a 5. And so if I want to go all the way across, it's 25. And then from K to L is where they marked Z. On the green triangle, it looks like if I go from J to M, it's 5. If I go from M to L, that's X. And if I go from L to J, That's the y. And then finally, for the red triangle, if I go from M to K, I need a 20. If I go from L to M, that's my X, right? L into M. And then the last side from L to K is Z. So now we should be able to see how all these pieces line up and how we can make our proportions. So if I want to solve for X, I've got an X here and an X here. So that's where I'm going to use my proportions. So I can say X over 5 equals 20 over X. Solve by cross multiplying, so X squared is going to equal 100, which means X is equal to 10. So again, that's where our geometric mean calculation comes in. Okay, so for Y. So I've got a Y here. See, and I've got a Y here. So it looks like I can do 25 over Y equals Y over 5. So again, do your geometric mean. So Y squared equals 125. And so I can break that down just like we talked about a few minutes ago. So I know that 125 was 25 times 5, which means I'm going to put 5 root 5 as my answer. Finally, to get Z, so we got a Z here, and we have a Z here. So it looks like we can go Z over 20 equals 25 over Z. So Z squared is equal to 500. And if I square root that and simplify it down, Z is 10 square root is 5, because again 100 times 5 gives me 500, and the square root of 100 is 10. All right. Last example. So here's just a little word problem illustrating how we can use this in a real life situation. So if we read through the little paragraph, the setup, we notice that we're looking for the height X of the bleachers. If we set it up and draw out that triangle, right, X is here, 10.5 is here. If I take that smaller triangle and rotate it around so that everything matches up, right, 5.75 would be my shorter leg, and 10.5 would be the larger. So this time when we set up our proportion, X is not going to be the geometric mean, but it's still going to be helpful. So X over 10.5 equals 10.5 over 5.75. And then we're just going to cross multiply and solve for X. So if we do that, X times 5.75 should equal 10.5 squared, which is 110.25. And so therefore X is 19.2. And that's all I have for today. I will see you guys next time.